Hello everyone, welcome back to our series dedicated to space settlement contest. I'm sorry for my voice because I'm a little bit sick, but today I will teach you about artificial gravity, how to create it and why do we need it. So let's start. So what is artificial gravity? In some sources, for example in science fiction, artificial gravity is a force that pulls you to the floor of a spaceship. So for example, we have a rocket. So the rocket has floor and we have people push it down to this floor by the force of artificial gravity. But in this example, this force is created by nothing, so this force is not really possible setup for us. Thus, we need to find a more suitable way to create an artificial gravity in our station. So, what are the ways to create gravity in our space station? Well, there are some ways to create gravity. First is obviously the gravity itself, so the force of attraction, force of gravity. But this is not a viable strategy for us because to achieve a gravity similar to the gravity on Earth, we need a mass of our space station to equal mass of the Earth. Obviously, this is not possible, so this variant is not suitable for us. So, the second way to create gravity on our station is electromagnetism. This is much more likely rather than force of gravity because this force requires much less mass and no mass at all because it requires electrical charge. But in order for this to happen, we need to have everything on our station to be charged at some rate. So we will have to put magnets on our people and things and everything. So this will be costly exercise. This will require a lot of work and a lot of energy because electricity requires energy. So this is not suitable for us. So third and the most likely way, which you could have already guessed, is centrifugal force. So centrifugal force is the most likely way to create artificial gravity on a space station. Why? Because we can easily spin our space station. It is one of the simplest exercises we can do, so let's do it. Now, what is centrifugal force? So this force is inertial force, which by Newtonian laws means it is imaginary force. It is not a real force, but it has a real effect in our world. So how is it generated? We have a body moving through space and time. So we have our person. We need to artificially push into something. So we have our person and he needs to be pushed down with force. How does this happen? So we have this is a floor of our space station. It takes form of a circle with a radius r. And how does this happen? So when moving, our person wants to keep moving in the same direction, but because he spins on the floor of the station, he is pushed down, wanting to continue his way of going. So he wants to stay in the same place with the same speed, but because he spins along with our space station, he's pushed down with the force of gravity. As an example of this, I can use this card holder. I can spin it and I can feel the force of it pulling my finger away. So because I can feel the force of it pulling my finger away, I can conclude that it has force. But if I remove my finger like this, it flies in a straight direction, meaning that it won't spin without my finger spinning it. So the same process happens here. The man spins with the station, but if the station was removed, he would float straight into the void or into the space, whatever. So now that we know how the centrifugal force works, we can go to the formula. How to calculate formula for centrifugal force is to take centrifugal acceleration times mass of our object, but actually we need only acceleration because it requires to be the same as on Earth. So on Earth, as you know, G, or gravity, equals 9.81 meters per second squared. So on our station it should be something about 9.7 to 9.9 meters per second squared. It doesn't actually matter a lot because the difference is negligible due to structure of a station, so on, so on. So we'll probably just take 9.81 meters per second. So now, what is formula for acceleration for centrifugal acceleration? So acceleration centrifugal equals to angular velocity squared times radius. So angular velocity squared is every time a body moves around a circle, it moves around for 1 second, it passes angle alpha. So this angle alpha, we can take this as a measure. So angular velocity will be equal alpha divided by time delta. So difference of alpha divided by time, or the another formula of this equation will be alpha centrifugal equals W speed divided by radius. So it also moves with some constant speed within V1, V2, and V1 and V2 equals each other because it's like this. And the speed is always constant, so it's any formula you can choose, whatever. But for us, the most advised formula will be this one, because we can actually neglect this speed and only use the angular velocity. So what can we conclude from this formula? From this formula, we can conclude that the centrifugal acceleration depends on radius, and it also depends on angular velocity. So to increase the acceleration, we can increase either of those parameters, but as we can notice, it's more efficient to increase the angular velocity, because in this formula it is squared rather than it is to increase radius. So we can make smaller station, generate the same artificial centrifugal force, centrifugal acceleration, and it will take less resources. So let's do that. We can conclude that radius needed by our station will be acceleration divided by squared angular velocity, and so on. So angular velocity is acceleration divided by radius, and we can choose either of those formulas to work with. So, for example, if we have determined radius of 100 meters, so our station like this, it has a 100 meters radius that will stay the same throughout the station. To generate artificial gravity, we need to spin it with the force. We have this equation, so we can calculate that the angular velocity of our space station should be square root of acceleration required divided by radius. So it equals square root of 9.81 seconds divided by 100 meters. So angular acceleration should be around, well, we should put our calculators and it will be equal this amount. I will montage the right amount onto the final product. So yeah. Now, why do we need artificial gravity even? Why can't we bypass this? Why can't our astronauts float like on a space station, like on ISS? Well, there's multiple reasons for that. So the first reason for that being health of an astronaut, because each time an astronaut flies in gravity, without gravity, he feels no force on himself, so his muscles decrease, his orientation decreases, he can't stand on the ground, he falls like this, he walks like this, and he also forgets about his gravity. So when he wants to pass something, when he wants to do something, his objects just fall. And he's shocked because he used to, when he lets it go and it stays in the same place like this, or without the hand. So first of all, it is health. Another important matter for it is birth. Although you can, but it is very difficult and it is not advised to give birth in zero gravity. So obviously, to give birth on a space station, we should have a gravity too. And third is safety. So when you don't have any artificial gravity, you have not only humans and these objects floating around, but you also have your hair, you have your breadcrumbs, you have your, any dust, any, small graphite of your pencils when you like erase it with a rubber, anything. When it is all floating and it can get into small holes in ventilation, it can get into electronics, it can get anywhere and short circuit the entire station. And if you and even isolated parts, even if you short circuit it, it will fry everything we have, any progress we make. So it's very important to have safe measures against it, and the safe measures are actually very easy. It's just gravity, because you don't see anything short circuiting on our planet because of it. Because you have short circuiting, but for other reasons. Also, don't forget water, pee, any body liquids, any commercial liquids such as motors, motor oil, or lubricants. It all floats. It all can get somewhere and block something. It can damage. So yeah, we need to have the safety. And because the requirements for a space station, it should live about 100 years autonomously. Because of this requirement. Well, you should have gravity for people to get used to it, for people's anatomy to be used in the gravity, because, well, people's anatomy in the gravity change, so we should have gravity. Otherwise, after 100 years, another species will come, another species will appear, and it will be pretty much the same, but a different species. So no, none of this. None of this, I guess. That's everything for today. Thanks for watching. You can subscribe to our Instagram or Telegram or LinkedIn. It's all in the description. Thank you very much for watching, and come back for the next episode of the series.